Okay, hi guys. So this is Cycle K Phase 2 and the practice is on Delta Math. For the last one, the practice was attached, but here the practice is on Delta Math. So just go to Delta Math, you'll see Cycle K Phase 2 and just practice, practice, practice. So the derivative of a constant we know is 0, but the antiderivative family of a constant, so let's think about it. So basically, oh no, the cat. So basically, you got to think of 7 as a derivative. Okay, so if 7 is the derivative, then what was the original? If 7 is the derivative, then what is the original? It would be 7x plus c. Okay, it's a family. So the antiderivative of a constant, you just put an x next to the constant. And then, just think about it. What's the derivative of 7x? 7. What's the derivative of any constant? 0. And then that would get you back to 7. All right. So calculate the integral. So this is the first time I'm saying integral. So basically, guys, when they say integral, it just means antiderivative family. And usually they don't say family. I'm saying family to remind you of the plus c. Okay, the family means plus c. So they'll usually just say antiderivative or integral, but what it means is antiderivative family, both of those. So calculate the integral and write in the answer in simplest form. Okay, so these I took right from Delta Math. So in your Delta Math Phase 2, you're gonna see examples of all of these that are like all of these. So guys, I'm gonna do something that you don't have to do, but same way as the same thing as like a derivative. If you're taking the antiderivative of a number of terms, you think of it just as separate antiderivatives of each term. So for our notes, I'll write it like this. So this would really be the antiderivative first of 1, and then I could just put that minus like between them, and then we'll have the antiderivative next of 6x to the negative third. Okay, so what is the antiderivative of 1? It's the same as like this. So the antiderivative of 1 is just 1x. Oh, and I'll show you something in a minute. Don't worry about the plus c. We just put the plus c at the very, very end. Okay, that plus c will take care of all of the infinite numbers of members of the family. All right, then I'll bring down this minus. All right, now here the coefficient is 6. I'm going to divide 6 by the new exponent. So negative 3 plus 1 is negative 2. X to the negative 2, and then you do the plus c at the end. So this is x. This is negative 3, so minus negative 3. So x plus 3x to the negative 2 plus c. Okay, now this one. So we're going to have to do an aside here, guys. So the aside. All right, so this, what we are taking the antiderivative of, or the integral of, they're the same thing. What we're taking the antiderivative of, it's not a sum of things of the form ax to the n. That's what we want. So what we can do is expand this. So I'll just do an aside. 2x squared minus 1, 2x squared minus 1. So we're just doing an aside here. So this is 4x to the 4th minus 2x plus 1. All right, so this is really the integral or the antiderivative of 4x to the 4th. Because those, okay. All right, now, we don't have to separate the antiderivative or the integral for each term. We could just, think of them separately. So we're doing 3 separate antiderivatives. So this is equal to, so I'm bringing down the coefficient 4. I'm going to divide by 4 plus 1 is 5, x to the 5th, minus 4. I'm going to divide by 2 plus 1 is 3, x to the 3rd, plus the derivative of, or the antiderivative of a constant is just, the constant times x. So that'd just be x and then plus c. Yeah, so that was not bad. Oh, and guys, let me show you something also. So back up here. All right, so you could think of this as 7x to the 0. All right. So I bring over the coefficient. I divide it by the new exponent. 0 plus 1 is 1. X to the 1 plus c. All right, so that's another way. So this power rule for antiderivatives, that's actually what we're doing when we do this, the reverse of the power rule for derivatives. It just gives you this formula. All right, so that's another way. Okay, now something like this. Again, not of this form or this form. So we're going to also have to do some kind of like aside. So I'll do an aside here. So you can split this up because the bottom is just a monomial. Okay. And then, so what this ends up being, guys, and I'm going to simplify. So this is 21x to the second minus 5 plus 8x to the negative 2. All right, so we have to have each part in the form so we could use the power rule for antiderivatives. All righty, so I bring down the coefficient. I divide by the new exponent, so 2 plus 1 is 3, x to the third, minus 5x. Okay, so antiderivative of a constant, plus 8 divided by the new exponent is negative 1, x to the negative 1 plus c. All right, now I gotta just simplify. So 7x to the third minus 5x minus 8x to the negative 1 plus c. Okay, guys, so now you want to go to delta math and just practice, practice, practice. You want to be as comfortable with this, taking the antiderivative of this stuff, as you are taking the derivative of this stuff.